By the end, you'll have a 12-month plan aimed at 4 artifacts: a public repository, controlled CPU experiment, reproducible 4 to 6 page mini paper, and feedback revision log. This blue notebook is the route from curiosity to research practice. Here's the proof route. One laptop loads scikit-learn's 1,797 handwritten digits, each 8 by 8. We sweep a few widths under controlled label noise, freezing the train validation test split, seeds, and stop rule before any curve. It's a scaled-down double descent adaptation. The outcome is unknown. One blue notebook carries the evidence. Question, frozen plan, raw rows, repository, mini paper, criticism, revision. It keeps the home lab honest, because every promise must become inspectable. First plot is not a trophy. A linear baseline and tiny MLP set a fair starting point. The width sweep asks one bounded question, with no results selected in advance. Practice is not a PhD, affiliation, visa, job offer, or acceptance. Degrees can still provide mentorship, networks, signaling, and access. This route claims only research capability. $0 means no tuition, subscription, paid course, API, or cloud bill in a reference path. Not zero laptop, electricity, internet verification, time, or opportunity. Free quotas may change, so CPU is the anchor. University training supplies foundations, paper reading, narrow questions, fair evaluation, reproducibility, writing, and feedback. Public course pages expose that sequence. They are maps, not enrollment or credit. OLA's warning is the tension. Outside a degree, replace structure and mentorship with deliberate support and visible proof. So what can a beginner test before buying compute? Start like Carpathy recommends. Inspect data, build an end-to-end skeleton, establish a baseline, fix seeds, visualize, and validate before scaling. Your first win is a boring result you can explain, not an impressive model you cannot audit. Months 3 and 4 are paper literacy. Use a triple read. Scan the structure and figures. Restate the hypothesis, method, and result in your own words. Then reread for one specific question. Make 4 2-page memos and 1 citation map. Months 1 and 2 stay deliberately unglamorous. Python, NumPy, Git, linear algebra, probability, gradients, and supervised learning. Build one notebook with a train validation test split, a linear baseline, a metric, error analysis, and a plain language assumptions note. Do not collect courses as trophies. Each memo narrows the question: what mechanism is claimed, which variable changes, what counts as evidence, and what could fool you. The notebook earns a next page only when the previous one changes a decision. In months 5 and 6, choose a mechanism small enough to test. Our example adapts the double descent question. As model width grows, contest error dip, rise near interpolation, and dip again under controlled label noise. The dataset is scikit-learn's built-in handwritten digits, 1,797 samples, each an 8 by 8 image. Those small tiles fit a normal laptop CPU, so the experiment is about discipline measurement, not renting a giant cluster. Use a linear model and tiny MLP as sanity baselines, then sweep widths with fixed label noise. This is a scaled-down adaptation, not an exact replication, and the curve remains unknown until you run it. Before the confirmatory run, freeze split, noise rate, widths, optimizer, epochs, seeds, metric, and stopping rule. Write them first. A plan after pretty curve is a story. A plan before it is a test. Run at least 3 pre-registered seeds and keep the baseline fair. Spinning up emphasizes simple systems, instrumented metrics, repeated seeds, and ablations because one lucky run can manufacture confidence without knowledge. How we stop cherry picking. Save every raw row. Width, seed, noise, metric, wall time, and failure status. Keep null curves, crashes, and unstable runs. they show what not to assume. Compute locally first. Collab and Kaggle are optional bursts. Free resources are not guaranteed, unlimited, or stable. If a GPU vanishes, the reference experiment still runs on CPU, so the plan degrades gracefully. Do not force a famous shape. Check whether this tiny setup produces a double descent-shaped test error pattern under stated conditions, or a null or messy result. Either outcome is evidence about the adaptation. Months 7 and 8 turn reproduction into a question. Pre-register one extension, clean versus noisy labels, a changed regularizer, or a different split. Change one variable, and state the comparison before running it. Report convergence warnings, timing, missing rows, seed sensitivity, and 8x8 limitations. A tiny experiment cannot establish a universal law. It can establish exactly what this code, data, and protocol did. This is where reproduction becomes research practice. Rerunning a known effect is a gateway, not originality by itself. Your ablation, failure analysis, or narrower question is the new claim, and its boundaries must be visible. In months 9 and 10, package the work for inspection. Pin versions, data provenance and license, config and seed files, one-command reproduction, raw CSVs, plots, and a README saying what is not tested. Write a bounded 4 to 6 page mini paper. Question, related work, method, evaluation, results, limitations, and next experiment. Plain language is a strength when every sentence maps to a row, plot, assumption, or unresolved uncertainty. Can a stranger rerun it? And can criticism change the claim? Make a public artifact, not a promised publication. AR14 has moderation and category rules. Open review follows its venue, and neither grants automatic peer review. Version control is part of the argument. Commits show changes. A public repository exposes history. Free GitHub Actions may automate public project checks, but hosted limits and runner rules still apply. Months 11 and 12 recreate the missing lab function. Ask 2 people for bounded review. One checks whether evaluation tests the claim. One follows reproduction instructions. Record comments, revise code and wording, and publish the diff. Independent work can be lonely and slow. Madsen's experience shows feedback and collaborators matter, and that a successful paper route was not literally costless. Build a critique network of peers, maintainers, or a careful reader. Keep the career boundary visible. Thomas points to writing, apps, experiments, and open source work as evidence. When notes ML roles differ and research scientist screening can favor advanced credentials. A portfolio proves practice, not hiring eligibility. Contribution work has a quality bar. The Transformers Guide asks for a self-contained reproducer, environment details, tests, minimal changes, and clear motivation. Code volume is not evidence. A stranger's rerun is closer. The honest $0 stack is simple. MIT materials for learning. AR14, Open Review, Semantic Scholar, OpenAlex, and Zotero for discovery. Python, Jupyter, NumPy, scikit-learn, PyTorch, Git, and a public repository for building and sharing. Recheck access before a 2027 release. Free software, data, weights, and interruptible compute are different things. Licenses, quotas, account rules, and course pages can change. The CPU path protects the core claim. Your completion scorecard is 9 checks. A falsifiable question, baseline, changed variable, 3 pre-registered seeds, every raw row, an ablation, a reproducible public repository, a bounded mini paper, and 2 reviews with 1 revision diff. Each week, make the notebook answer 3 questions. What did I change? What did I measure? And what decision follows? That rhythm prevents passive course accumulation and keeps the project small enough to finish, inspect, and revise. Tonight, create the Blue Notebook's first page and write. In 12 months, I will publish 1 reproducible AI experiment with code, raw results, a 4 to 6 page report, and a feedback revision log. Then reserve 1 hour for the first baseline.